So now let us see what could be the solution to this problem. The only very obvious solution is that both the transmitters should transmit the signals in different frequency range. In fact, every transmitter should have its unique frequency range of the signal which it is transmitting. Now, how can I combine this solution with the solution of the first problem? In the first problem, we said that we cannot transmit low frequency signals directly because we will require large size antenna for that. We will convert the low frequency signal to high frequency signal and then transmit the signals to the receiver side. Hence, we will need some high frequency signal for this conversion to take place. Now, let us say if I use different high frequency signals for different transmitters, then the high frequency signal which I will be generating will also be of different frequency range. For example, let's say I will make transmitter 1 to use high frequency FC1. I will make transmitter 2 to use high frequency FC2. So for example, when the transmitter 1 transmits the signal 20 Hz to 20 kHz, it will be first converted to some high frequency signal which will be present around FC1. When transmitter 2 transmits the signal 20 Hz to 20 kHz, it will be first converted to some high frequency signal which will be present around FC2. Because both the signals are converted to high frequencies, the size of antenna problem is solved, and now the high frequency signals which both the transmitters are transmitting are present in the different frequency ranges. So if receiver wants to listen to the first transmitter, I will tune receiver to FC1, and when I tune receiver to FC1, it will only receive signal from the first transmitter and the signal from the second transmitter. Because it falls in the separate frequency range, it will be blocked. Similarly, if I want receiver to receive signal from the second transmitter, we will tune the receiver to FC2, and that's how it will receive signal from the second transmitter now, and the signal from the first transmitter will be blocked because it will be present around FC1. So the same process of modulation will solve the second problem also. All we'll have to do is use different high frequency signals for different transmitters. Let us discuss third problem involved in this setup, and again let's have the common solution in the form of modulation process. So at the end of the discussion of the second problem, you guys must have got a brief idea on what is modulation process. So all we have to do is convert low frequency signal to some high frequency range. And for doing this, we will need some high frequency signal which can be of different values for different transmitters. Let's go to the third problem and its solution. Let us discuss the third problem with a few calculations. We discussed in the first problem that the size of the antenna required is lambda by 4. Let's calculate values of wavelengths for two different frequencies. For F1, which is let's say 1 kilohertz, we have already calculated its wavelength, which comes out to be 3 into 10 raised to 5. For one more frequency, we will calculate its wavelength. Let me take this frequency to be 15 kilohertz. Please note that 15 kilohertz, it's a valid audio frequency because the range of audio frequencies is 20 hertz to 20 kilohertz. So lambda 2 comes out to be 1 by 5 into 10 raised to 5. Now if you take the ratio of lambda 1 by lambda 2, this ratio is 3 upon 1 over 5. 10 raised to 5 will cancel out, which will be equal to 15. This means that if length of an antenna to transmit frequency F2 is let's say L2, and if the length of the antenna to transmit frequency F1 is let's say L1, what will be the difference between L1 and L2? The ratio of their lengths, let's find out, will be how much. To transmit F1, because F1 is smaller frequency, the height of the antenna required will be larger, so L1 will be greater than L2. So if I take the ratio L1 by L2, the ratio L1 by L2 will come out to be same as lambda 1 by 4 upon lambda 2 by 4, as the size of the antenna or the length of the antenna required is of the order of lambda by 4. 4 will cancel out, and lambda 1 by lambda 2 we have already calculated, which is equal to 15. That means the length of the antenna which will transmit F1 should be 15 times greater than length of the antenna that will transmit F2. Let me tell you that this ratio we have obtained for frequencies 1 kHz and 15 kHz. If you increase the gap between the two frequencies, then the ratio between the lengths of the antennas will also increase. So the conclusion from this discussion is that to transmit different frequencies, we will need different sized antennas. We will need antennas with different sizes. And this will again be a problem, because even if I can manage, let's say for a moment, if I assume that problem 1 does not exist, I can manage large size antenna which will be of the order of few kilometers, let's say.